Welcome back to another deep dive on the explainer. Today, we're unpacking a perspective that completely flips the current tech narrative on its head. We're looking at the vision of Meta's chief AI scientist, Yann LeCun, and his, honestly, pretty profound critique of the current generative AI hype. For years now, the whole industry assumption has basically been this. If we just scale up large language models, throw more data at them, throw more compute at them, human-level intelligence is just going to naturally emerge, right? Well, LeCun fundamentally disagrees. It's a super provocative question, isn't it? I mean, are these massive generative models, the ones writing our emails, coding our software, completely dominating the headlines, are they actually a dead end for true human-level intelligence? If our ultimate goal here is an AI that genuinely understands, predicts, and interacts with the real world, LeCun actually argues that the auto-regressive paradigm, generating data one piece at a time, might literally be a roadblock to artificial general intelligence. And I absolutely love this quote because it brilliantly illustrates his core philosophy. Listen to this. You could memorize every cookbook ever written and still have no idea what food tastes like. Think about that for a second. An AI can process trillions of words about gravity, or robotics, or cooking, but just predicting statistically plausible continuations of text, that is not the same thing as grounded understanding. Basically, language models are out there memorizing the entire cookbook, but they aren't actually experiencing the kitchen. Okay, so let's quickly dive into our roadmap for this explainer. First, we'll look at the illusion of LLMs. Then, why language isn't reality. After that, we'll get into the world model solution, followed by a breakdown of how JPA actually works. And finally, we'll wrap up with the architecture for advanced machine intelligence. All right, starting with section 1, the illusion of LLMs. Great for short-term business, not AGI. Now, to be completely clear here, LeCun is definitely not saying these models are useless, far from it. Just look at the sheer scale on this slide. This graph from Meta shows their NLLB 200 model successfully translating over 200 languages. So yeah, LLMs have clearly found their market. They're absolutely incredible at reducing the cost of producing text and translating information, but here's the catch. These successes rely on the statistical continuity of a sequence. The model is amazing at extending a pattern, but that doesn't mean it's actually building a robust representation of physical constraints or real-world causality. So the crucial thing we need to understand is exactly where auto-regressive generation hits a brick wall. First off, LLMs lack a persistent world model. They literally have to reconstruct context from scratch with every single forward pass. Second, no hierarchical planning. They just generate step by step, totally lacking the ability to break down a massive abstract goal into smaller subtasks. And third, this is a big one, they suffer from exponential error accumulation. Because they're just predicting the next token based on the previous ones, a single tiny mistake early on just compounds at each subsequent step, and that leads directly to those infamous AI hallucinations, where the system will super confidently, and sometimes hilariously, defend a complete logical impossibility. Which brings us to section 2, why language isn't reality, the lossy compression of the physical world. To really grasp the limits of text-based AI, we kind of have to realize that language is, well, it's just a lossy compression of reality. Think about this, practical comparison for a second. Literally any 10-year-old can learn to clear a dinner table in one shot. Any ordinary house cat can plan the complex physical actions required to jump up onto a high shelf. But current AI, it cannot do this. Why? Because animals and humans learn internal models of how the world works mostly through physical observation and physical interaction, not by reading a bunch of text. I mean, we learn intuitive physics, gravity, and object persistence way before we ever learn our first word. By training AI exclusively on text, we're basically starving it of the foundational common sense knowledge that actually drives true intelligence. Moving right along to section 3, the world model solution, a $1 billion paradigm shift. Now the industry is betting huge on this paradigm shift, with companies like AMI Labs actually raising over $1 billion. And you can see the direct contrast between these paradigms right here. On one side, large language models are totally text-centric. They're hyper-focused on predicting the next token and statistical completion. But on the flip side, world models are reality-centric. They are explicitly designed to model environments, understand causal relationships, and focus on physical actions. It's a massive shift from a system that just passively holds linguistic knowledge to one that interactively understands how physical spaces and actions actually work out in the real world.
To define it formally, a world model is an internal representation that allows an AI system to evaluate sequences of actions by predicting their physical consequences. Think of it essentially as a mental sandbox. Just like you can close your eyes right now and perfectly imagine what will happen if you swat a glass off your desk, a world model allows the AI to forecast future states of the world, and from there it can select the safest, most effective actions to achieve its goal.
Okay, section 4. How JEPA works. That stands for Joint Embedding Predictive Architecture. I really want you to take a close look at this architectural diagram from LeCun's research. So on the left side, you've got your traditional generative models. What do? They take an observation, run it through a predictor, and try to reconstruct the exact raw output, like literally every single pixel in an image. But then look at the architecture on the right. This is JEPA. Instead of predicting those raw, noisy outputs, it runs both the past observation and the future target through an encoder. And then it tries to predict the abstract representation of the future in a latent space. So it's essentially aiming for a compressed understanding of the core concepts, rather than worrying about the raw pixels.
So, what's the big deal here? Well, the crucial point is efficiency and focus. Generative models waste massive amounts of computational power trying to recreate totally irrelevant details, stuff like the exact texture of a single leaf, a random moving shadow, or just visual noise. JEPA, on the other hand, predicts stable, latent variables, forcing the system to learn only what is semantically meaningful. It completely avoids what LeCun calls representation collapse by focusing entirely on the underlying structure of reality rather than just faithfully copying the noisy, unpredictable surface of a signal.
And that brings us to section 5, AMI Architecture, the blueprint for human-level AI. So, where is all this research actually heading? Let's walk through how this builds sequentially into a complete cognitive system. Step 1 is perceiving the world through sensory inputs, like video, so it can learn intuitive physics. Step 2 requires a persistent associative memory that doesn't just magically reset with every single query. Step 3, well, that's where the world model really kicks in, allowing the system to plan hierarchical actions, evaluating a bunch of different futures before actually making a move. And step 4 is absolutely paramount, controllable safety. Because this is an objective-driven architecture, safety constraints are literally baked into the core design. That's totally unlike LLMs, where we just, try to patch unsafe behavior through some superficial fine-tuning after the fact. Now, interestingly enough, LeCun completely rejects the buzzy term artificial general intelligence, or AGI. As he puts it, superintelligence doesn't mean it's general. It just means slightly better than humans in some domains. I mean, think about it. Human intelligence isn't entirely general either, right? We're actually highly specialized. So the real goal here isn't to build some omnipotent, godlike machine, but rather to build systems that have a truly robust mental model of our physical world. Systems that can assist us effectively and safely in our daily lives. We'll leave you with this final thought today. The AI industry has spent the last few years completely captivated by the magic of next word prediction. But as we start reaching the limits of what pure statistical language modeling can actually pull off, we really have to ask ourselves, will the true next leap in artificial intelligence come from companies burning millions of dollars in compute just to predict words? Or will it come from architectures designed to genuinely predict and understand physical reality? Thank you so much for joining us on this explainer. Keep asking those big questions, and we'll see you next time.